Hi, my dear Telangana warriors. Let us quickly start lesson 4 Refraction of Light by Curved Surfaces. And one more thing, I am calling you as Telangana warriors. Warriors means Yuddha Veerulu. Why am I calling you guys as Telangana warriors? See, since we teach every day three different boards, what are they? CBSE, Andhra Pradesh, and Telangana. These are the three different boards every day we teach, and we know how many more concepts and how much depth concepts are there in your class 10th mathematics and of course in physics also. For example, your lesson 1 and lesson 4 together they have kept in one lesson, and that too very easy and less number of concepts they have included in their physics. So that is the reason I am calling you guys as warriors with the Veerulu. So let us quickly start our lesson 4 discussion as part of Fatafat Dhanadan session. So as part of our Fatafat Dhanadan session, now we are going to discuss some important topics of the fourth lesson. What are they? Different types of lens, ray diagrams, characteristics of images, and focal length of a lens depends on surrounding medium. Then sign convention rules and formulae, important formulas, and based on them we are going to solve some problems. So let's start our discussion with our first topic, that is different types of lens. And you can see here on the screen double convex, double concave, plano convex, plano concave, and convexo concave. These are the 5 different types of lens you might have seen in your textbook. Now, this double convex lens we can also call as convex lens due to our laziness. Similarly, this double concave lens we can also call it as concave lens again due to laziness. Now I have an important question for you. What is that? Are you lazy? నువ్వు లేజీ స్టూడెంట్వా? If you are a lazy, then please raise your hand. I am repeating, if you are a lazy student, please raise your hand. Now you might be surprising why am I asking this question. See, if you see this laziness in terms of positive, then there are so many benefits. For example, ఎర్లీ హ్యూమన్ బీయింగ్స్ అంటే ఆది మానవులు అడవుల్లో ఉండేటప్పుడు దే ఇన్వెంటెడ్ వీల్. దెన్ విత్ ద హెల్ప్ ఆఫ్ వీల్ దే హ్యావ్ ఇన్వెంటెడ్ సైకిల్, బైసైకిల్. బికాస్ వై షుడ్ ఐ వాక్? ఇన్స్టెడ్ ఆఫ్ వాకింగ్, లెట్ మీ డూ సైక్లింగ్. Next, again, because of laziness, why should I cycle every day? They invented motorcycle. Again, it is just because of laziness. Then again, due to natural challenges like cold, hot, and rainy, they have invented car. Then again, when they are traveling on the car nicely, they have lot of traffic, and they are facing so much problems on the roads like accidents. So they invented flight. So my dear students, if you are a lazy fellow, what you will do is, when you want to draw this double convex lens, you will think some alternative shortcut, and that shortcut is only, or the symbol for this double convex lens only is this. So due to laziness only we have invented this symbol, and this is the symbol of double convex lens. And when you have to draw the ray diagrams related to double convex lens, you have to use this symbol. Similarly, we have a symbol for double concave lens also. So if you see positively the laziness, it has so many benefits. I think all of you know drawing ray diagrams is the most important topic of your class 10th physics. So now we are going to discuss rules to draw ray diagrams. And if you see here on the screen, we have a double convex lens. Now there is an incident ray which is parallel to principal axis. Let us take one more incident ray. This is also parallel to principal axis. Now what happens to these two incident rays when they are coming and falling on the lens? ఏమవుతుంది? అవి లెన్స్ నుంచి బయటకు వస్తాయి. ఆ బయటకు వచ్చిన రేస్ని ఏమంటాము? రిఫ్రాక్టెడ్ రేస్ అంటాము. నౌ ద రిఫ్రాక్టెడ్ రేస్ will pass through focal point. See here on the screen. For this incident ray, when the refracted ray is coming out, that refracted ray passes through this focal point. Similarly, this is the incident ray which is parallel to principal axis, and its refracted ray also passes through focal point. This is one rule. Let us discuss another rule. Here, incident ray itself will be passing through focal point. This is one incident ray, this is another incident ray. Both these two incident rays are passing through focal point. మరి అప్పుడు రిఫ్రాక్టెడ్ రే ఎలా వస్తాయి? ఫ్రమ్ దిస్ లెన్స్ బయటకు ఎలా వస్తాయి? సో ద రిఫ్రాక్టెడ్ రేస్ ఆఫ్ దీస్ టూ ఇన్సిడెంట్ రేస్ will be parallel to principal axis. For this incident ray, this is the refracted ray when it is coming out from the lens. And for this incident ray, this is the refracted ray which is coming out from the double convex lens. So the rule says incident rays which are passing through focal point, their refracted rays are parallel to the principal axis in case of double convex lens. This is another rule. Let us see third rule. Here incident ray itself is passing through principal axis. See clearly, incident ray itself passing through principal axis and incidenting at the optic center. So what happens? Its refracted ray will be also passing through principal axis. Actually here refraction does not happen because it go in a straight path. When do we say refraction? When it is bending. But here after incidenting, this is not bending, it is going straight. Let us take one more incident ray which is falling at the optic center of the lens. Now, do you think it will bend like this or like this? No. The incident ray which is incidenting at the optic center, it does not deviate, it go in a straight path. So, this is what your third rule says. Now, with the help of these rules only, we are going to draw ray diagrams. Again, are you lazy? నువ్వు లేజీ స్టూడెంట్ వా? If you are a lazy student, what you will do? Instead of drawing this lens as shown here on the screen, what you will do? You will draw the symbol of this double convex lens as shown here. Again, rules are same. See here, you can see the animated rays of incident and refracted. Similarly, for the next rule, instead of this lens, what you will do? You will draw the lens with the help of symbol, and these rays again which are passing, incident rays which are passing through focal point, will be parallel to principal axis when they are coming out or when they are refracting out from the lens. Again, you can see the third rule with the help of the symbol of double convex lens. So this is how you can use the symbol and draw the rules. Let us now discuss the most important topic of your class 10. What is that? Ray diagrams of images found by convex lens. And to draw ray diagram, what do we need? We need the knowledge of how to draw, means rules to draw ray diagrams, and that is what we have discussed just now. So now using those rules, we have to draw ray diagrams. So we have convex lens here, where between P and F. You can see here between P and F. P here in case of lens we will call it as optic center. And let us take one incident ray which is parallel to principal axis. So what happens to this incident ray? The incident ray which is parallel to principal axis passes through focal point. So see here, this refracted ray will be passing through focal point. Let us take one more incident ray, and this incident ray is passing through optic center, and its refracted ray, when it is refracting from the lens, it does not bend, means it does not deviate, it does not refract, it passes in the same straight path. So the incident ray which is passing through optic center does not deviate, it will pass in the same path. Now these two refracted rays will help us where the image will be found. And if you observe these two refracted rays, their distance keep increasing. And if you put screen here, they will never converge. It means they will never form real image. Then what happens? In this case, when the object is in between P and F, a virtual image will be formed here in case of convex lens, where here this is the object and this is the image of this object when the object is between P and F, and this is the ray diagram. And if you talk about characteristics, this image is erected, enlarged, virtual, because it is not forming on the screen. Now, if you are a lazy fellow, what you will do? If you are lazy, instead of drawing this lens, you will draw the symbol, and you can draw same ray diagram as we discussed just now. See here on the screen, this is the ray diagram with the help of symbol of convex lens. Now let us discuss about how to draw ray diagram when the object is at F. So here you can see object is at F. Again, we need to follow two rules. What are they? Let us take incident ray which is parallel to principal axis. So it passes through, refracted ray passes through focal point. Let us take one more incident ray which passes through optic center. It does not deviate, it will go in a straight path. And if you observe these two refracted rays, they will be converging somewhere very far away. For example, if it is converging here, highly enlarged inverted image will be formed. So this is how you need to draw a diagram when the object is at F. Again, if you are a lazy fellow, what you have to do? Instead of drawing this lens, you can draw this symbol, and as shown here, the complete ray diagram you can draw. And if you talk about the characteristics, the image will be highly enlarged, inverted, real, and at infinity, the image will be formed when the object is at F. Let us draw one more ray diagram when the object is between F and C, or C and F. So again, we are going to follow the same rules. We are going to take first of all incident ray parallel to principal axis. Its refracted ray passes through focal point, and we will take incident ray which is passing through optic center, does not deviate, go in a straight path. These two refracted rays are converging here, so image will be formed here only. And same ray diagram with the help of the symbol of convex lens we are going to draw. So this is how the image will be formed when the object is between F and C. And if you talk about these characteristics, this is enlarged, inverted, real, and where it is forming, it is beyond C. The image is forming beyond C when the object is between C and F. Now let us discuss the most easiest and important ray diagram when the object is at C. See here, you can see the object is at C, and we are going to follow the same rules, and these refracted rays are converging here. It means image is forming at C. Same ray diagram with the help of the symbol of the lens, convex lens, you can see on the screen. So finally, this is the ray diagram when the object is at C. And if you talk about the characteristics, object, this is object height and image height, both of them are same. Object at C, image is also at C. This image can be caught on the screen, so it is a real image and it is inverted. So the conclusion is same size, inverted, real, and at C the image will be formed when the object is at C. Now let us discuss another ray diagram when the object is beyond C. See, this is C and object is beyond C, and rules are same. Incident ray which is parallel to principal axis and optic center. Finally, the refracted rays are converging here, where the refracted rays are converging between F and C. It means image will be formed here. Again, same ray diagram with the help of the symbol of lens we can see on the screen. Now, when the object is beyond C, where the image is forming? Image is forming between F and C. What kind of image? Object is this much height, image is small, so diminished image will be formed. when the object is beyond C, and image will be inverted between F and C, real image will be found. So these are the characteristics, and this is how you need to draw ray diagram when the object is beyond C. Let us now discuss the last ray diagram. You have 6 different positions, so you should learn 6 different ray diagrams of convex lens. So now when the object is at infinity, see here on the screen, this is incident ray and this is the refracted ray. Let us take one more incident ray, and its refracted ray is also passing through focal point, because these are the parallel rays which are coming from the object which is at infinity. Same way, with the help of this symbol of convex lens, we can draw the same ray diagram. In the exams, you can go ahead with this ray diagram instead of this ray diagram. I mean, మీరు ఎగ్జామ్లో ఇలాంటి రే డయాగ్రామ్స్ డ్రా చేసినా ఓకే, because they are comfortable. One thing, when the object is at infinity, what kind of image is forming? See, this is the image. The size of the image is very small, means point-sized image. It can be caught on the screen, so it is a real image. And it is forming at F. So when the object is at infinity, image will be forming at F, point-sized, inverted, real image will be formed. Let us now discuss characteristics of images found by convex lens. And this is actually the result of our ray diagrams. Just now we have drawn ray diagrams. Now, there, whatever the characteristics we have identified, those characteristics we are putting in a table. And these are the 6 different positions. Between P and F1, at F1, between F1 and C1. So these are the 6 different positions which we have seen in our ray diagrams. Here, one doubt you may be having. What is this F1 and C1? For example, this is a convex lens and you are putting object here. For convex lens, you will have focal point this side, center of curvature this side. Similarly, for this convex lens, you will have focal point this side, center of curvature this side also. Means convex lens will have 2 focal points, 2 center of curvatures. If I am putting object here, then this side focal point and center of curvature, I should call it as a F1 and C1. That's it. So now come back to the characteristics. If object is between P and F1, only in this case, erected virtual image will be formed. Only one case, erected and virtual image will be formed. Remaining all cases, inverted and real image will be formed. If you talk about the size, when the object is at C1, only in this case, same size image will be formed. Remaining all cases, either enlarged or diminished image will be formed. So these are the different characteristics and these are the different positions of the image. Now how to learn? Actually, you need to draw first of all blank table. With the help of your ray diagrams, you fill up on your own this table. Then check how far you are drawing this table, means how far you are correctly filling this table with the help of our table. You draw table and fill up this table with the help of ray diagrams. Then come back and see this video. Check whether you are filling the table correctly or not. So this is how you need to learn the characteristics of images formed by convex lens in first lesson, concave mirror. Same characteristics and the way of learning just now I told you. Let us now discuss another important topic, that is sign convention rules. And this topic is helpful for 2 lessons. What are they? Lesson 1 and lesson 4. So your first sign convention rule says that all the distances should be measured from pole. Second rule is related to distance. So the distance which is measured in the direction of incident ray should be taken as positive. That is the first point in the second rule. Second point, the distances which are measured opposite to the direction of incident ray should be taken as negative. So finally, your second rule or sign convention rule is related to distance. Third rule is related to height. If any object above the principal axis, you need to take that height of the object or height of the image, you need to take positive. If object or image, anything is below the principal axis, then you have to take that height as negative. So these are the sign convention rules, and let us discuss with the help of these sign convention rules. This table will be helping you a lot, in which case you need to take focal length as positive, in which case you need to take focal length object distance negative. All these things we will easily understand with the help of this table. So this table is really going to help you to apply sign convention rules while you are solving any problem related to concave and convex mirrors, concave and convex lens. So if you see here, concave lens, focal length, object distance and image distance. For concave lens, all of them are negative, means FUV. Whereas for concave mirror, focal length, object distance and image distance you can take minus, but in only one case you have to take plus. What is that? If object is in between P and F, then V, image distance, you have to take positive for concave mirror. So this table please utilize properly while solving problems. And remember one important point, it may be any mirror or any lens. In all the cases you have to take object distance U negative only. Next, let us discuss important formulae and problems which are there in your lesson 4, refraction of light by curved surfaces. In this lesson, you have mainly 4 formulas. What are they? Curved surface formula, lens maker's formula, magnification of lens formula. But in terms of problem solving, you have to mainly focus on lens formula and magnification of lens formula. So these two formulas are more useful and more expected problem solving formulas. So if you want, again you can take screenshot and note down all these formulas, and next let us solve some problems using these two formulas, and of course we have to use sign convention rules also to solve the problems. So now let us solve some problems using formulas and sign convention rules. If you look at the problem here on the screen, calculate image distance if an object is placed at 60 centimeters where in front of a convex lens whose focal length is 20 centimeters. So let us note down what is the given information in the question. So they have given focal length 20 centimeters, object distance 60 centimeters, and they are asking us to calculate V is equals to question mark. This is the given information. And if you observe carefully, we have taken focal length positive, object distance negative. Why? Because just now we have discussed sign convention rules, and in the problem they said about convex lens. For convex lens, we have to take focal length positive, object distance negative. So that is the reason we have taken focal length positive, object distance negative. Now to solve this problem, let us use our lens formula. So this is the lens formula. What is that? Everybody say along with me. 1 by F is equal to 1 by V minus 1 by U. This is the lens formula which we are going to use to solve this problem. Now we want to calculate V is equals to how much? So we are transposing this 1 by U. So after transposing 1 by V is equals to 1 by F plus 1 by U. In place of F, substitute 20. In place of U, substitute minus 60. So when you substitute, you can write as shown here, and plus into minus, you have to write minus. So that is what we have written. And if you observe denominators, the LCM will be 60. So after taking LCM, you can write 3 minus 1 by 60, because 20 into 3 is 60. So 3 into 1, 3. Similarly, 60 into 1, 60. So 1 into 1, 1. Now after simplification, you will get 2 by 60 and then 1 by 30, and we want V value, but we got 1 by V. So let us take reciprocal of these two ratios, then you will get V is equals to 30. Finally, we got V, image distance is equal to 30 centimeters, and here there is nothing, means plus is there, no symbol is there, means plus means real image is formed by the convex lens. So this is how we need to solve the problems which are given based on mirrors and lens. And of course now we have discussed lens related, and we use it lens formula to solve this problem. If you want, you can once have a look at complete solution. Let us now discuss another problem. Here, calculate height of the image. If height of the object is 3 centimeters and magnification product of convex lens is 1.5. So what they have given in the question, see here. H0 means height of the object 3 centimeters, M magnification product 1.5, and they are asking us to calculate height of the image. So Hi is equal to how much? This is the question. So now to solve this problem, we are going to use magnification of lens formula. What is it? M is equal to V by U is equal to Hi by H0. This is the magnification of lens formula. In your lesson 1, you have learnt magnification of mirror formula. There M is equal to minus V by U is equal to Hi by H0. So their minus symbol is there, here minus symbol is not there. This is the important point which you need to note. Next, in our problem, Hi and H0 and Hi related things are there. There is no any work with this V and U. So from this formula, what we have to take? M is equal to Hi by H0. We are not taking this V and U. Now, when you transpose H0 towards left, you will get Hi is equal to M into H0. M value 1.5, H0 value 3 centimeters we have. So let us substitute. So if you put M is equal to 1.5 and H0 3, then you have to multiply, and after multiplication you will get 4.5. What is this? Hi means height of the image. Therefore, finally we got height of the image is equal to 4.5 centimeters. So, my dear Telangana warriors, this is how you need to use sign convention rules, lens formula and magnification of lens formula to solve the problems. Hope you got good clarity. If you want, have a look at once again throughout this solution through. Let us discuss another important topic of this lesson, our question. The question is, do you think focal length of a lens remains same if surrounding medium is air and water? Do you think focal length of a lens remains same in air and water? This is the question. So now let us first of all try to understand with one example here. See, without specs I cannot see clearly the letters, but when I wear and see the letters, then I can see little bit clearly. It means these lenses are affecting my vision. So this is little bit relevant to our question or topic. Now let us take a perfectly best example for our question. So here you can see on the screen there is a double convex lens, a black stone we have taken, and a lens holder. This is the lens holder we have taken, and let us perform a simple and easy activity to understand whether focal length of a lens remains same in air and water. So here we have two glass jars. In one glass jar nothing is there, means air is there. In this glass jar we are pouring water. So air and water we have in these two glass jars. Then let us immerse or put the stones in these two glass jars. Here we kept the stone, and same stone we are keeping in this water containing glass jar also. You can see here the stone. Now let us try to observe the stones which are immersed in these two glass jars with the help of this lens. This is the double convex lens. And here, now if you see the stone in air, this is the size of the stone you can see. When you observe from here through this lens, the size of the stone is this much. Now, do you think when you see the stone which is there here through this lens of same focal length, these two lenses are having same focal length, do you think now size of the stone is same? Let us see. When you are seeing, the size of the stone is bigger when compared to air. Why it is happening? It is because these two lenses are having same focal length actually in the air, but here the surrounding medium of this lens is water. In this case, surrounding medium of this particular lens is air. So surrounding medium is not same for these two lenses. So that is the reason the size of image of the stones is not same when you are observing from here through these two lenses. So the conclusion is focal length of a lens depends on surrounding medium. Focal length of a lens depends on surrounding medium. If surrounding medium is air, it will have some focal length. If surrounding medium is water, it will have some other focal length. Lens is same, but focal length is not remaining same. If you take same focal length of lens and put in diamond or kerosene or any other transparent material, then its focal length definitely changes, and that is what the conclusion of this question and activity and the topic. So once again I am repeating, the conclusion is focal length of a lens depends on surrounding medium. Very important question. So my dear students, as part of Fatafat Dhanadhan session, till now we have discussed all the important topics in this lesson, and the topics which we have discussed till now are different types of lens, ray diagrams, characteristics of images found by convex lens, and focal length of a lens depends on surrounding medium. Then we also discussed sign convention rules. Based on sign convention rules, we have done problems. So in addition to that, we have also discussed formulas, important formulas which are there in this lesson. So hope you will utilize all the topics which we have discussed. You will listen again and again and prepare your own running notes and follow all the instructions which we have given during our discussion. Thanks for watching and learning. All the best.